This is the video for notes on slide 28 through 30 for section 6.4. All right, so we are learning some more integral rules here. So you can see I have the rules here, but I want to make sure that you understand why these rules are what they are. So first thing that we're going to do is we're going to start off with the derivative rule. So d dx of the natural log of the absolute value of u. Okay, and so we know from Unit 3 that the derivative of the natural log of the absolute value of u is 1 over u times du dx. All right, and so we realize that this is a differential equation, right? It's an equation involving a derivative. So first thing we're going to do is we're going to multiply by dx. So if I multiply by dx, we get the dx's to go away. So I have d natural log of the absolute value of u equals 1 over u du. And so now we're going to integrate both sides. So now you'll realize that the right side of the equation is the rule that we're trying to learn. And so the integral of 1 over u du is, well, the integral of the derivative of the natural log of u. Well, remember, that would be the natural log of the absolute value of u, and then, of course, plus c. So that is the rule for the integral of 1 over u du. So remember, this is just based upon our derivative rules. All right? So the next one, okay, the integral of e to the u. So we remember that the derivative with respect to x of e to the u is, well, e to the u times du dx, right? Simple. So remember, we multiply by dx, and so we get the integral of, sorry, not the integral yet, d e to the u equals e to the u du. All right, and so now we want to integrate both sides. Now you'll remember that the right side of the equation is the rule that we're trying to learn. So what is the integral of the derivative of e to the u? Well, it's e to the u plus c. So the integral of e to the u du is equal to e to the u plus c. All right, and then the last one is the a to the u, right? So we recall the derivative rule involving a to the u. So d dx of a to the u is equal to a to the u times the natural log of a times du dx. So just like in the last two problems, all right, we multiply both sides by dx, so the dx's cancel out. So I'm left with d a to the u equals a to the u times the natural log of a du. All right, and so now we would integrate both sides. But one key thing that we want to keep in mind here, the natural log of a is a constant. So when we integrate both sides, we could actually bring that over and write it as 1 over the natural log of a times the integral of a to the u, the integral of d a to the u equals a to the u du. And so now we integrate here. The right side, once again, is the rule that we want to know. And so I have the derivative of a to the u, well, or the integral of the derivative of a to the u is a to the u. So I have 1 over the natural log of a times a to the u plus c, right? Equals the integral of a to the u du, right? So that is our rule, and I've chosen to write them like that. So those are ones that you want to make sure you are working to memorize, okay? So now we want to just make sure that we can apply this. All right, so slide 29. All right, if I have the integral of e to the 2x minus e to the 4x over e to the x, all right, so first thing I want to do is I want to think about a U-substitution. But if I were to take a U-substitution, you have to make sure that the derivative is there. So number one is actually kind of a tricky one. We're actually going to rewrite this as e to the 2x over e to the x minus e to the 4x over e to the x. So we're going to split it up and then ultimately write it as two separate integrals. So first of all, I have e to the 2x over e to the x. We subtract the powers and we just get e to the x minus e to the 4x over e to the x. That's e to the 3x. So now I want to take the integral separately. So integral of e to the x minus, that would be integral of e to the x dx minus the integral of e to the 3x dx. All right, so the first one is pretty easy. Integral of e to the x is just e to the x. And then, of course, plus c minus. Now, integral of e to the 3x. I technically need u equal to 3x. So du is 3dx. So I have 1/3 integral of e to the u times 3dx, right? But remember, 3dx is du. So now I have e to the x minus 1/3. What is the integral of e to the u? It's e to the u. So e to the 3x, and then, of course, plus c. So that would be my integral of the e to the 2x minus e to the 4x over e to the x. All right, the next one. All right, we want to think about a U-substitution. Remember, this is different than the first one. We cannot split it up because there is not a single term in the denominator. So I'm going to let u equal the denominator. All right, now why would u equal the denominator? Well, because then I have the integral of 1 over u times x squared dx. And remember, the derivative of 5x cubed plus 9 is 15x squared dx. And remember, I had x squared dx. So that means I need a 15 with the x squared dx and a 1/15 on the outside. All right, so now I have 1/15 integral of 1 over u du. And so 1/15, what is the integral of 1 over u? Remember, that's natural log of the absolute value of u plus c. So 1/15 natural log of the absolute value of 5x cubed plus 9 plus c. All right, so now anytime you have an absolute value, you want to potentially simplify if possible. Remember, absolute value makes something positive, but if whatever's on the inside is already guaranteed to be positive, the absolute value is not necessary. Now, 5x cubed plus 9, that is not always positive. Remember, if I were to plug in a number like -2 here, I get 5 times -2 cubed. That would be 5 times -8, -40 plus 9. That is not always positive. So we do, in fact, need to retain those absolute value symbols there. All right? But that is not necessarily always true. All right, let's move on to slide number 30. All right, so slide number 30. All right, I have the integral of cosine x times 3 to the sine x dx. All right, so remember 3 to the sine x. Remember, the sine x is inside of the other function, the 3 to the power function. So we want to let u equals sine x. So that means I have the integral of 3 to the u, and then I still have the cosine x dx remaining. Now that is nice because the derivative of sine is cosine of x dx, and that's what I have. So I have the integral of 3 to the u du. So now, integral rule for, well, we had a to the u. Well, what's the integral of a to the u? It's a to the u, so 3 to the u, divided by the natural log of 3, and then, of course, plus c. So we replace u with sine x. So 3 to the sine x over the natural log of 3 plus c. All right, now what's left? All right, so the last one looks actually very similar to number 2. So let's take a look at u equaling the denominator, 2 sine x plus 3. And so that means the integral of 1 over u, and then I have cosine x dx. Now, was this u a good choice? Well, the derivative of u, well, what's the derivative of 2 sine x? It's 2 cosine x. Sorry, I put plus c there. That should be a plus 3 there. All right, and the derivative of 3 is 0. So this is du equals 2 cosine x dx. So that's good because I had the cosine x dx, so I need a 2 there, which means I need a 1/2 on the outside. So now I have 1/2 integral of 1 over u du. All right, so 1/2. What is the integral of 1 over u? It is the natural log of the absolute value of u. So 2 sine x plus 3 plus c. Now, this is one of those weird ones that if you had this problem in your homework, you would not see this as your multiple choice solution or your answer sheet answer. So what you need to realize is that 2 sine x plus 3 does not need the absolute value. Why? Because it is strictly positive. So think about 2 sine x plus 3. Remember, the 2 would make the amplitude of the sine function go up to positive 2 and down to negative 2. And the plus 3 is a vertical shift. So that means if it was going down to negative 2, it shifts up 3. So now the lowest point is positive 1, which means that this thing is strictly positive. And if this thing is strictly positive, that means that the absolute value is unnecessary. So it would be just the quantity 2 sine x plus 3, not the absolute value. So that's one thing where if this was multiple choice, you would not see a multiple choice answer that has the absolute value bars because that would be redundant. All right? And so that one's kind of weird, but that's the way it goes sometimes. All right? So that's slide number 30.